Hello, my name is Eric Velasco, and in this opportunity we are going to talk about Singapore's air quality management and climate change monitoring. Since its inception as independent nation, Singapore understood very well the importance of solving all environmental problems for the well-being of its own population, as well as a key strategy for convincing foreign investors that it was a well-planned and sustainable city. The first air quality assessment was conducted over 50 years ago, in 1970. The results and findings of this initial assessment were used to enact the Clean Air Act 1 year later. In 1999, the Environmental Protection and Management Act replaced the Clean Air Act, and this has been updated regularly. Singapore follows a unique strategy based on an integrated urban and industrial planning, strict enforcement programs, pragmatic and cost-effective policies, and a flexible approach to changes in technology. All of them together have allowed Singapore to achieve a dynamic economy and a high-quality living environment. The Ministry of Sustainability and the Environment formulates and reviews all strategic policies related to Singapore's environment. The National Environmental Agency, NEA, is the statutory board that implements such policies. Air quality management and climate change mitigation are under NEA agenda. The Ministry of Sustainability and the Environment, MSE, is committed to achieve a clean and sustainable environment, as well as building a resource-efficient nation and a climate-resilient society. For such endeavor, the Ministry of Sustainability and the Environment, together with other four ministries, launched in 2020 the Singapore Green Plan. This plan charts ambitious and concrete targets over the next 10 years, aiming to reach sustainability by building a circular economy and becoming a zero-emissions nation by 2050. About air quality, Singapore comes with a network of 18 stations monitoring air quality at ambient level and 4 at roadside. Sulfur dioxide, PM10, nitrogen dioxide, ozone, carbon monoxide, and fine aerosols, PM2.5, are the 6 criteria pollutants considered in Singapore. For air quality purposes, the city island is divided in 5 regions. Every hour, NEA publishes the rolling average concentrations of each criteria pollutant, and with them calculates a pollutant standard index. In addition, every hour provides an air quality descriptor based only on 1 hour PM2.5 concentrations for the sake of informing about the instantaneous air quality conditions. The question of $1 million. Is air pollution still a problem in Singapore? Well, Singapore doesn't present air quality problems like other large cities throughout the Southeast Asian region, like Manila, Jakarta, Bangkok, Ho Chi Minh City, etc. However, air pollution is still present. The worst air pollution episodes are triggered by massive wildfire across neighboring islands of Indonesia. However, in Singapore, we count with our own emission sources, enough to produce air pollution episodes. Industries or refineries, we have the busiest port in the world, and Singapore doesn't count with an emission control area. It means that ships can burn whatever fuel they want. Changi Airport is a major emission source of atmospheric pollutants. Over 1 million vehicles are on our roads, and we cannot close eyes to our own very particular emission sources, such as the burning of fake money during the Hungry Ghost Festival. Besides, to the north we have Johor Bahru in Malaysia, and to the south Batam in Indonesia, and together they make up a metropolitan area of 8.4 million inhabitants. This time series of fine aerosols shows that air pollution in Singapore exceeds almost every day international thresholds. Here we use as reference the interim target number 4 proposed by the World Health Organization of 25 micrograms per cubic meter. In Singapore, we never exceed air quality standards. And the reason is because we don't have standards, we have targets. And how does these targets compares against international thresholds? Well, they look a bit lax. Only carbon monoxide is not a problem at all. Sulfur dioxide, nitrogen dioxide, PM10 present concentrations not extremely high but exceed those international thresholds. As any other modern city, Singapore struggles to control PM2.5. PM2.5 is the pollutant of major concern in Singapore. This chart is used to inform in general about Singapore's air quality conditions. At first glance, it seems that air pollution is not a problem at all, but if we pay close attention, we will see that authorities are not lying, but are not telling us the whole history. Air pollution in Singapore causes almost 1,400 premature deaths every year. This represents 24 deaths for every 100,000 inhabitants. And the air pollution cost reached 2.4% of the national GDP. This is a lot of money. And when we come across advertising like this, we may think that something weird is in the air, and it is. Asthma can be triggered by many reasons, but air pollution is one main reason. And Singapore sadly presents one of the highest asthma rates worldwide. 1 in every 4 teenagers suffer of asthma here. To wrap up the discussion about air quality monitoring, we can affirm that Singapore comes with a robust air quality monitoring network, but we do not know where the stations are located, which pollutants are monitored at each station. In addition, real-time data, 1-hour concentrations, are not available. We only count with hourly concentrations for PM2.5 and NO2, but not for the other criteria pollutants. And records from past years are not open to the public. Similarly, we don't know anything about precursor pollutant species, such as the volatile organic compounds that, in the presence of polluted atmospheres, boost the production of secondary pollutants such as ozone and an important fraction of secondary particles. In the same line, we don't know anything about the chemical processes occurring in the warm and humid atmosphere of Singapore. And meanwhile, we don't know anything about these mechanisms, we won't be able to understand the production of pollutant species such as ozone. And in turn, we won't be able to explain changes over time and design better control measures. The same is true for aerosols. We don't know which is the chemical composition of the particles that we breathe in Singapore. Regarding emission inventories, Singapore only counts with emission estimates for sulfur dioxide and greenhouse gases. According to my knowledge, no spatially and temporally speciated emissions inventory is available in Singapore. However, we can make use of international emissions databases like EDGAR. From there, we can retrieve emissions for Singapore and see how they have evolved throughout the time. About air quality modeling, again, according to my knowledge, no operational air quality model is in place in Singapore. Air quality models are needed to learn from past air pollution episodes, as well as to evaluate the effectiveness of new environmental policies. Nowadays, many environmental agencies are running on a daily basis air quality models as forecasting tools. This allows them to warn people in advance of any air pollution episode. Jumping to greenhouse gas emissions, every second year, Singapore updates its emissions inventory of greenhouse gases to the atmosphere as part of its national communications to IPCC. The emissions inventory is constructed following bottom-up approaches, I mean using emission factors and activity data. The methodology is straightforward, but is subject to uncertainties. Uncertainties coming from the own activity data and associated with emissions factors representativeness. According to my knowledge, I don't know of any validation system based on field observations, such as exercise of inverse modeling. As part of our own research, we deployed during 7 consecutive years a eddy covariant flux tower in a low-rise neighborhood. With this tower, we measured directly and continuously all major and minor carbon contributions and carbon sinks in a footprint of a similar area of a complete neighborhood. This is what we got. We observed higher carbon dioxide fluxes to the atmosphere at night and lower during daytime. It looks a bit suspicious because we may expect higher emissions during daytime. To explain this pattern, we built our own emissions inventory for this sector of the city, and we found a disagreement. And happens that we didn't account for vegetation. During daytime, we have the photosynthesis effect, at night, respiration. To validate our findings, we designed a series of experiments to evaluate the individual contribution of each component of the green landscape. Putting together all components, soil respiration, carbon uptake from turfgrass and trees, and including emissions associated with maintenance activities such as pruning, mowing, trimming, etc., we found that the green sector is capable of offsetting up to 8% of the anthropogenic emissions within the boundaries of this neighborhood. But this is only true under an ideal waste disposal management. If all garden waste is sent to an incinerator, we will lose all carbon gain. Extending our findings to the entire city, considering the 112 square kilometers covered by turfgrass and 6 million trees, we found that Singapore's green landscape is capable of offsetting almost 1% of the anthropogenic emissions reported in the official emissions inventory. Before wrapping up this talk, if you would like to learn more about Singapore's air quality management and climate change mitigation, I invite you to read the papers that we have written about these topics. For closing, 2 words: transparency and accountability. Any environmental achievement in Singapore is very important throughout the Southeast Asia region. Happens that many cities see Singapore as the model city to follow. Thank you.